All right, so welcome everyone to the second session in the Common Core series. As mentioned, this is JavaScript Fundamentals for everyone. And the purpose of this is to have the fundamentals of JavaScript. The different tracks will all use JavaScript to one extent or the other. So this first week is just the fundamentals of it. And the next week, when we break into the different squads, each squad will learn more JavaScript that's specific to their purpose and what they do. Right now, the JavaScript we're learning is all on the base of Node.js. And so we're using Visual Studio Code with Node.js to write our JavaScript and practice it, okay? So yesterday we looked at variables. We looked at how to declare variables, right? We learned about keywords. We learned about statements. We learned that a program is just a series of statements executed one after the other, right? And so we learned about the let keyword. That's for declaring a variable that you can change. We learned about the const keyword, which is for declaring a variable that you can't change, right? We learned what an identifier is, which is essentially what you call a variable. We learned some best practices around that. And then, most importantly, we learned the console log statement, which is how you output to the console, okay? That works in browsers, it works in Node.js. We also learned operators, right, which is how you perform operations on data, so on variables, on constant, on variables, on literal values, so on strings, on integers. You have operators that you can, use to modify the data or perform operations on the data. We looked at Boolean operators, which you use to perform operations on Boolean values, true, false, 0, 1. Essentially, binary values are what we call Boolean, right? And then we learn, of course, how to write a script in Visual Studio Code and execute that script. So today we'll pick up from all of that. And we're going to use all of that in everything that we do today. So if some of it didn't stick yesterday, every class will build on the previous one, and you're going to use that knowledge, you're going to reuse it, and with repetition, it's going to stick. So don't freak out if it seems, like you're not catching it initially. It's going to get easier because we're going to constantly repeat the concepts in practice. The other thing I will say is that I will use technical terms because it is important to call a spade, right? If you go for an interview, you're going to have to use the right terminology, right? You can't go for an interview and they ask you, oh, what's concatenation? Or, what happens when you have a string, a plus, and you're like, oh, it is when it joins this thing to this thing. You can't use this thing, right? You have to use the term concatenation, and then they know what you know what you're talking about. Okay, so I will use technical terms. You don't have to memorize them, but you will remember them with time because we'll use them constantly over and over and over again. So an identifier is an identifier, right? That's the right thing to call it. Okay? All right, let's get started. I will share my screen and we'll jump into today's class. So, control statements. As discussed yesterday, programs typically run line after line after line, right? From line 1 down, right? They typically just run from top to bottom. But imagine how difficult it would be if that was the only way programs could run, right? If I wanted to write a script that would do one thing for one group of people and a different thing for another group of people, right? Imagine if I wrote that linearly. How do I tell it to skip this part for one group of people or only execute this part for another group of people, right? Or imagine if I had logic that I wanted to be executed 100 times, right? The program only runs linearly, it will run once. So what do I do for it to run 100 times? Do I copy it and paste it 100 times? So flow control or flow statements help in controlling the flow of the application such that you can have it go up on a branch or execute code conditionally, or you can have it run in a loop, and that is when it executes code repeatedly, right? So it repeats, it just keeps looping around within that block of code as long as a particular condition is met, okay? So those are the two main types of flow control or control statements that we have. So we're going to look at each one. Remember, there's the conditional, which means it executes that based on a condition. And then there are loops, which means it repeats it a certain number of times. And you, the programmer, define how many times, okay? So we look at conditional statements. Conditional statements are statements that control program execution based on the result of a Boolean comparison, right? If I said boys wear blue, girls wear pink, right? I would say if you're a boy, wear blue, else wear pink. That's a conditional statement. So conditional statements are if-else statements, right? Now, you can also have if, else, if, else, right? Where I can say, okay, if you're between 0 and 10 or 0 and 13, right? Your classification is child. Else, if you're between 13 and 25 or 13 and 20, your classification is teenager. Else, your classification is adult, right? So that's an if, else statement, okay? And we're gonna examine each type. There's also a switch case statement, which is when you have too many if, else if, else if, else if, then the way to solve that problem is using a switch statement. You'll see what that means. It sounds like Greek right now, but when we do it, then it's gonna make sense. And then the final one is a ternary statement. This uses the ternary operator, okay? And the ternary operator is the question mark. So we're gonna get into that as well. It's a shortcut for if else, okay? So let's look at the first type of statement. It is if a condition, else, right? So you have a block of code. A block of code is these curly braces. This is the first time we're going to see them. And that's called, these are called curly braces. So this is an opening curly brace and a closing curly brace. If you want to find it on your keyboard, it's usually just under the equal sign, plus equal, right? Close to the backspace. It's on the second line under backspace, right? So it's near the end. It is usually shift and the square bracket will give you the curly bracket or the curly brace, okay? So this, between these two, is what we call a block. And that is how you group many statements into one group. I will demonstrate this so it makes more sense. So I'm going to switch over to Visual Studio Code here, and still in the hello.js file that we used yesterday. I'm going to do this. I'm going to say let x equals 5, right? And let y equals 6, right? Now we'll say if, and then in parentheses is our condition, right? Remember it, the syntax, and I'm going to switch back and forth. If condition, then the code we wanted to execute, else the other option. So it's a branch. It's going to take one path or the other based on the condition. So here I'll say if, and then inside the parenthesis, x is greater than 6, right? Here on the next line, I'll say console.log. This makes no sense, right? And then here I'll say else. And we can now say console.log. This makes perfect sense. Okay. So when I say this, who knows what the output of this will be? And I'll unmute. Anyone? So anyone, you can unmute yourself now, actually. Can anyone guess what the output here will be?
It should be, this makes perfect sense.
All right, so let's run this. I've saved that file and node, hello. All right, this makes perfect sense. So if we analyze it, remember the program is running from top to bottom, right? But it comes here and it evaluates this condition right here. And it says x greater than 6, this returns false. So it skips to the else. Okay? And that is how you branch it. Okay? Now, if I wanted to add a condition here, let's say, here I say else if, and then I define another condition. I will say x is equal to 5, right? I will say, and I'm going to remove this. Okay, and here we can say console.log this, sorry, this has to be in quotes, so we can say this is logical, right? Now, who can guess what the output here is going to be this time?
An error message this time.
Why
Say
is
this is logical.
No, else if you put bracket there.
Oh yes, sorry, I put the wrong parenthesis here. Yes, I will have an error here. Sorry, else if this is supposed to be open. All right, so now the code is correct. So, what do you think this output would be?
This is logical because it hits that one first.
Yes. So else is only if any of these conditions don't match. So if it's this, if this is true, it will go into that next line. If not, it will go, if not, it will try this condition again. We have another if here. If x is 5, it will come into this line. And if neither of these is true, then it will come into the final line. So let's run this and we will see that. Okay, says this is logical. Okay, so this is conditional logic. And this is an if, else statement. Okay. All right. I'll take a pause here. Any questions? Okay.
Can you go over the condition and the else again, please?
Yes. So right here, you're talking about this one or the else if?
Both.
Okay. So it is just the if else is a simple branch, right? If this, then do this, else do this. So if the condition doesn't match, if the condition matches, you do whatever is in the if. If not, you do whatever is in the else. Now the else if allows you to introduce a new condition. So it's like chaining another if to it, right? So if this condition doesn't match, it goes here and then it says, oh, you have another condition. It checks that condition. If it still doesn't match, then it goes to the else. The else is like the catch-all. You know, if you're 10 to 0 to 13, line up here. If you're 13 to 20, line up here. Everybody else line up here. That's kind of what this is. Okay. All right.
Yeah, hello.
Okay.
Do we have to put console.log at after every condition?
No, console.log is what we're asking it to do. We could do anything in here. We're only using console.log, like I said, to output to the screen. Console.log is what makes it show up.
Okay, and then I noticed between 2 and 4 that you left the 3 blank.
Yes.
Does it matter?
It doesn't matter. And we will do that as we go along. You'll notice that I indented the code. I'm leaving spaces there. There's best practices for formatting your code so that it is more readable. But don't worry about that for now. Empty lines are not a problem. Okay, we'll just keep that line.
I also wanted to ask about the open brackets. So the curved brackets are closing on another line.
Yes.
And then the new code starts on that same line. Is that also for better reading or?
Yes, it is also a coding standard. So the else is right there, but the curly braces are on separate lines. And that is because I could have multiple lines here. Console.log, something else, right? So I could keep going. I could have a lot of logic. In typical programs, you have more than one line in an if else, okay? So you have this at the end of it, and it's on a separate line. But we'll talk about all that formatting, okay?
I'm sorry.
All right, so let's move on. When I finish the block, then I'll open up for questions again. Is that okay? All right. Okay, so let's move on to the next one. And we're going to come back to this. We're going to use this in a few minutes. We're going to use it, but I need to be able to move so that we can use it. So the switch, like I said, is when you have multiple if, else if, else if, else if, right? Rather than having if, else if, else if, else if, else if, else if, the best practice is to use a switch statement, and then you define cases, okay? This is not, you won't use this as commonly, but you'll have occasions where you're going to use it. And I'm going to do an example here. And what you notice here with the switch is that the final catch-all, where if none of the cases match, is called default. So if nothing matches, then you have a default block that will be executed. That is similar to our final else. So if I want to change this, well, I won't change this because changing these kinds of expressions, right, to switch is a little more complex. So I won't do that right now. I'm going to do something different. So I'll say let main Okay, let's do this. Let country equals USA, right? Then we're going to say switch country, right? Country is the value we're evaluating, and then is the variable we're evaluating. So if the value of country is, so we'll say case USA, right? Console.log, we speak English, right? And then break. Case France, right? Console.log, we speak French, break, right? Case Italy, say console.log, we speak Italian, break, and then default. Console.log, are you even human? And break. All right, so this has some special syntax here. Case is the comparison. If what you're saying here is we're going to be looking at the variable country, right? If USA is, if country is equal to USA, then we come in here. If country is equal to France, we come in here. If country is equal to Italy, we come in here. If it doesn't match any of those three, we come into this line, right? So that is what the case means. The break is the keyword that tells you that is the end of that case, because you could have multiple lines of case, right? You could have it do multiple things. You could have multiple statements in there. But in this case, we only have one statement. And remember, for now, we're just using console.log. That's a basic statement. And that's just the output to the console. All right.
Excuse me.
Yes.
Yeah, please, I observed that this one, you have just two open and close parentheses at the
Yes.
beginning and at the end, compared to the first one that we had so many.
Yes. That is
So,
because, like I just said right now, the break statement is what tells you where the end of each case is. So the whole switch is one block.
oh,
The
I
break
see.
statements here tell you where the case ends. So that's a syntactical difference. And as you use it, you will remember. Okay?
Okay.
Don't try, yeah, you can't memorize these things. They're not meant to be memorized, they're meant to be understood and used. So the first time you use it, you'll probably have to look at reference, right? And then subsequent times, then you won't need to, because you've used it to get used to it. Similar to how when you're speaking English, you don't memorize every single word in the dictionary, right? No, you learn how to use words in context. So when you learn how to say good morning, you learn how to greet. So you learn good morning, good afternoon, good evening, right? They may explain what the meaning of good and evening is, but you typically will just learn that, okay, the way to say, to greet someone in the morning is good morning. That's a similar concept here, is you won't learn and memorize every single keyword. You learn how to do certain things. The very first time you try to do it, you might have to look at the reference material. You might have to look at the book and then do it You might get errors. When you correct it, it will become easier and eventually you won't even have to look. Okay, so let's run this and let's play with this. So right now here, our variable is set to the string USA. This is a string, it's in single quotes, right? This is our assignment operator. So this line is familiar, right? Because this is how you assign a value to a variable. So let's run this and see what our output is. So our output here, oh, sorry, I haven't saved this. I'll save this and I'll run that. And our output here is we speak English. If I changed this string here to France, right? And I save that and I run it, it says we speak French. So you see that it comes to the case, it checked this. Nope, no match. It checked France, it found a match. Break says I'm done. I've got what I need. No need to keep going on. So it exits this block at this point. That is the reason this is a break. It breaks out of here. And then if I have another line of code here, console.log this this line, right? And I save that and I run it. You see that? It found a match, came out of the block and continued on this line. It didn't even evaluate these next ones. Okay? Once it finds a match, it just keeps going. So if I change country now to Italy, right? And I run this, says we speak Italian. And the last one now is if I change the country to Japan. And I run this, it goes into the default block because it didn't find any match. So whatever I change this to, as long as it's not one of these three, it will be default. If I change it to James, which is not even a country, right? Are you even human? Okay. So this is the switch case conditional flow. It's very, very useful because the conditions are a lot more visible and the buts, so you can have multiple conditions here.
Can I ask a question on this one?
Oh, sorry. Okay. Please ask, and then I'll move on to the next.
If my conditions are more than 3, is there any reason to ever use an if-else then?
If you have more than 3 conditions, don't use if-else if. No. Okay.
Thank you.
Yes. Now you can, but anyone reviewing your code or looking at your code is gonna flag it because it's considered not best practice. Okay, so once you have multiple conditions, use switch and case. Okay. Now the last one here that we have is the ternary operator. This, for me personally, is my favorite. Right? It's my favorite. And what it is, it's actually a simple if-else. But it's a simple if-else that does nothing but assign a value, right? It's essentially you use it to assign a value conditionally. I'll show you what it is. So, no, actually I can show you here. So if you look at this on the screen, right? This is how a ternary operator works. You have this question mark after the condition, and you have a colon to separate the if and the else. It's very cryptic, but when you get used to it, you will love it because you see this one line here does the same thing as all of these lines here. And so we can break it down. What I'm trying to do here is I'm trying to assign a color based on the gender variable, right? I'm trying to say that, okay, if gender is male, the color is blue. If not, the color is pink, right? I want all male to be blue, anything else pink. That's a simple if else. Now, rather than having to define color and then do if gender is absolutely equal to male, assign blue to color, else assign pink to color. Rather than have to write how many lines? 1, 2, 3, 4, 5, 6 lines. Rather than having to write 6 lines. With this ternary operator, that's this one right here, I can do it all in one line. And this is how the assignment works. I will say let color equals, and then this is my condition here. Gender equals to male is my condition. This is the same thing as my if, right? So gender, if you want to read it like in English, you say, is gender male? If yes, blue, else, pink. That's kind of how you read this. So with the question mark, is gender equal to male? If the answer is yes, then we assign blue to color. If not, assign pink to color. So let's try that in Visual Studio Code so it will become more visible. We'll say let color equals, okay, let's do this. First, we need to define gender, right? So let gender equals male, right? We've defined that variable. So now say let color equals gender equals to male, right? Blue, pink. That's it. And so we say console.log color. And if I save this and I run this, wait, hold on. Oh, I didn't put this in quotes. So you see the error I get here? Reference error, male is not declared. And that's because I did not put quotes around it. So it thinks it's a variable I'm trying to use. So I have to fix that, save that, and run this again. And right here, give me blue. And then if I come here and I change this to female, and I run this, it gives me pink. If I change this to anything else apart from male, it will always give me pink. If I say undeclared, right? It'll give me pink. If I don't initialize the variable, that means if I don't give it a value. Remember, you can do that with let, right? With const, you can't. You must always declare a value with const. But with let, you can. If I come here and I don't give a value, what do you think will happen? Anyone?
Pink.
Pink. So let's run that. And we get pink. This here is a simple if-else statement. That's what this question mark operator is. Now, the beautiful thing about it, one of the reasons it exists is because I can actually even do this better. I can come here and I can skip even saving it as color because all I wanted to do was output it, right? So I can just say console.log and you know what? Exactly the same result. What it says here is console.log, okay, if this is the same thing as saying if gender equals male, console.log blue, else console.log pink. That's it. Don't beat yourself about it too much. This is one of the more, I've met seasoned developers who still trip over this line. I personally love it because it's very, very nice and clean. It saves me time, so I can write code much faster doing things like this. I will push towards using it as we work in the different sessions. You know, when I look at your code, I'll exercise it. Like I'll ask you to try to make it a ternary wherever it applies, and you'll get used to it. But I just wanted you to know that this exists. And when you look at the presentations yesterday for operators, and we had the logical, was it not the logical operator? Yeah, the comparison operators. It was one of it, but I skipped it yesterday. I didn't explain it because I was waiting for today. All right. So those are conditional statements. Okay. I'll pause for a minute. Any questions?
I tried doing the switch with different values. I guess, like you said, we don't need to get it perfectly right now because I'm getting an error, but I don't know if you want to see it or want to move on to something else.
Let's move on, but tell me what the error is.
Expected identifier. I'm very sure I'm missing some comma somewhere.
So expected identifier. So in your switch, yes.
No, it said unexpected.
Oh, unexpected identifier.
Yeah.
That means you may be missing quotes around a string value.
Gotcha.
Yeah. So you may have something that's supposed to be a string.
Don't worry. Let me not keep the class. Right. Keep the class back here.
Okay. So that is those are conditional statements, and I'll just summarize it quickly before we move on. We have the if else. Essentially, if one condition do something, else do something else. That's how you control how a program goes. And you're going to do that a lot, right? You've probably seen where you, you know, you click on something like maybe on a website and it says, are you sure you want to continue? And you click yes or no, right? What is behind that is typically a condition that says if you click yes, then it will take you on. If you click no, it will take you back, right? So that's kind of how you use conditional statements to direct the program to go one way or another, okay? The next one we're going to look at is loops. Loops allow you to run the same block. Remember, a block is between two curly braces. There's an opening curly brace and a closing curly brace, right? And the right terminology for it is curly brace or curly bracket, right? It's different from square brace or square bracket, and it's different from parentheses, okay? So a curly brace, opening curly brace and closing curly brace define a block of code. When we do loops now, you will see it will demonstrate better how blocks of code work. So a loop is how you have a program run, or a section of code, a block of code run multiple times. You define how long or how many times it will repeat, right? A loop cannot run infinitely, right? If you have an infinite loop, that's a loop that does not have an end, your program will crash. Like your program will literally crash. It's one of the biggest causes of crashes is when you have an infinite loop, right? So, and there are controls in programming languages to prevent that. But your loop must have a duration or a certain number of times it has to run. So there are three different ways of defining loops, like three basic ways. Let me say basic because these are not the only ways, but there are three basic ways of defining loops. They all do very similar things with a slight difference on the do while loop, and we'll look at that. But they all, you define how many times and you define what you should do, and the program will run that. So let's look at the for loop, right? The syntax for the for loop is you define a variable and initialize it, right? You define the condition that as long as that condition is true, the loop, the code in the block will execute as long as the condition is true. And then you define an incrementer. For loops are typically incremental, right? Or decremental, because you can have it go backwards. I'm going to explain what that means, okay? But remember these are the three requirements for a for loop. Is an initialization of what it is you're going to track, a condition that's a check on that variable you're tracking, and incrementation or decrementation of that variable you're tracking. Let's break it down. Here, if I say for, right, and I say let I equals 1. That's my initialization, semicolon. If I say I less than, right, 10, that's my condition. And I say I plus plus. That's my increment, right? Now, if I come here and I say console.log I, what's this going to do? It's going to print the value of I every time. So it will check this. Oh, I is 1. Is 1 less than 10? Yes. Come in here, run this, and then increase the value of I by 1. To check it again, I is now 2. Is I is 2 less than 10? Yes. To execute this, increase it. Is 3 less than 10? It will keep going until it gets to a point where I is not less than 10 anymore, and then it will stop. Okay, let me run this and you will see it clearly. You will literally see it on the screen. There. The first time, I is 1, it outputs it. I is 2, outputs it. I is 3, outputs it. All the way to 9. Once I becomes 10, this condition becomes false. And that's a loop. If I wanted to output something, sorry, this is nothing. If I want to put in another line, and I say console.log, the current value of I is, right? I save that. You see that? It's repeating it. It's repeating that every single time in the loop because it is within the block. So whatever is within the block will be run as long as this condition here is true. Okay. Now that we've said that, how do you make this also output 10? You notice it's stopping at 9. So what would we change to make this output 10 as well?
Instead of saying less than
Equals.
less than or equal
Less
to.
than or equal.
Less than or equal to. Yes. We change this to less than or equal to. And we save this. And we run this. And we now have 10. Once it tries to go to 11, it's like, oops, oh, 11 is not less than or equal to 10. I'll stop here. That is it. This is a simple loop, right? Now, if I wanted it to count the numbers backwards. I need a volunteer. Who's going to help us with that? I want it to go from 10 to 1.
I would equal 10.
Okay, that's the starting point.
And then
I will be greater than or less, greater than or
greater
equal
than or
to
equal to 10. Yeah.
Okay, greater than or equal to 10 or 1,
1.
right? And then
I dash dash.
so I minus minus.
Yep, I minus minus.
So we're decrementing it now and run that. So there you go. Backwards. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
3, 2, 1.
Okay. Let's use our first loop to do something more exciting. So let's start from 1 to 100, right? So we're going to start with I equals 1, I less than or equal to 100. And we're going to add all the numbers from 1 to 100. Who knows what the answer of that is? Anybody? If you add all the numbers from 1 to 100, what do you get?
You mean the sum of all the numbers?
Yes. So let total start here. And we're going to use an operator that we used, that we saw yesterday. Total plus equals I. Remember that? So we're increasing total by I, which is essentially just adding to total. And then we're going to say console.log the total is and total. Okay. And if I run this, so for the nerds there, that's the total of all numbers from 1 to 100.
So you were asking us if we knew this offhand.
Yes.
And you're not serious.
I was actually going to say something like 200.
Yes. So if you add all the numbers from 1 to 100, you will get that.
Can you replace the less than or equal to 100 with a less than 101?
Yes, you can. So if I did that, less than 101, you get the exact same result.
Nice.
Okay.
Can I
So,
check? Can I check
yes.
something?
Mhm.
Your last line. If you put that last line,
Sorry. Please unmute yourself again and ask that.
okay, that last line, the one where you output to the console. If I put that last line in the curly braces,
Mhm.
does that mean I'll get the answer for every count from 1 to 100?
Yes, you'll get a running total. So let's try that.
Okay.
So
Thank you.
if you wanted a running total, right? I'm going to take this line here, and I know how to do this in Vim. So okay, well, there you go. And I save that here, and I run it. It will give you a running tally, which is pretty cool to see. So let's just run that and see. And there, you have a running tally all the way from. So it starts from 1. 1 plus 2 is 3. 3 plus 3 is 6. Plus 4, 10, 15. You have a running tally all the way.
Why is the curly line, the curly bracket thing, braces looking guy, why is that on a separate line all the time?
It always is because it is not part of the statement. So if I put it here, and it is just for visibility, the compiler doesn't care. But if I put it here and you're reading this code, it's hard to miss where it ends. It's much easier for you to track the 4 with the closing curly. You see what I mean? So that helps you understand where that block ends. So when you have a block statement, like this, so you have a block of code. That curly makes it easy for you to see, to line it up. You can see that the Visual Studio Code actually also drew a line there between it.
Why
Something,
doesn't start
yes. Mhm.
the
Something,
start one? Why doesn't it go on a separate line?
so for some programming languages, the best practice is actually to do this, right? Some programming languages ask you to do this in their best practice. For the JavaScript coding standards, and there are some JavaScript coding standards as well that ask you to do this. For the ones that we will use, we wouldn't do this because with JavaScript, lines of code matter, right? Because they affect file size. Okay, the lines of code actually matter. So this, you have the readability, but you don't have the extra line that's unnecessary.
Do you mean even if you have empty lines?
Yes, empty lines matter, but we'll talk about that later. Empty lines matter, so you don't use them unnecessarily. So it's bad practice. It's okay for me to do this, right? That separates my variable declaration from this for loop. This is more readable. This is good practice. If I do this, this is bad practice. If I do this, this is very, very bad practice.
Gotcha.
Right. So it's okay to put one line in between for readability, but it's not okay to put two lines in between. Right. You can do this. This is good. You can do this. This is better. Okay.
Okay. Please, what is on that console.log line? What is the syntax after the total is? I'm struggling to read what you have in between.
Plus equals, that's the increment assignment. So we did this yesterday. Okay, so
no, not that one. On the console.log line, that line 5.
Oh, this one.
Yeah.
Just a comma.
Can you consider increasing your zoom?
Oh, okay.
Zoom amount, yeah.
Yeah, you have to zoom in on my Zoom because my screen is large.
No, I mean you increase the zoom on your Visual Studio Code. Right now your zoom might be at 1. Increase the zoom value so that your text is larger.
Yeah, that's a complex thing I need to do. So I can't do that right now. But on Zoom, you can zoom in on Zoom.
Why is
gotcha.
You can zoom in on Zoom. Okay, let's proceed because I want to make sure we keep moving.
Sorry, I have a problem on my end. How do I stop? I have an infinite loop on my end.
Yeah, press Control C.
Okay, thank you. I basically left out the semicolon on line 1.
Yeah.
And I had I minus, and so it's been counting backwards and
yeah. So press Control C. Also, your problem is more likely in the condition here because this condition was constantly met. It never results in a false.
Yes.
So make sure your condition is right. Because if I switch this right here and I say I less than, if I change it to greater than 101, right? Actually, if I change it to greater than 101 here, it will not run at all because this condition is never met. But if I have a condition where, for example, if I say I equals 1 and I have plus here, right? And I change this to I greater than 0, it will run forever because any number above 0 is greater than 0. So, okay, I'm going to mute everyone and then we'll move on to the next one, okay? But this is the for loop. You're going to use this a lot. It's a very nice, very comfortable loop. The next loop we're going to look at is very similar to the for loop. It's a little simpler in its syntax, but you won't find it as commonly. And I will show you, and we'll see if we can figure out why. So the next one we're going to look at is the while loop, right? It's simpler, like I said. you can use it instead of a for loop if you want. It's great. But the way it works is that you say while a certain condition, then you have the block of code you want to execute every time that condition is true, right? Now, if that condition is never true, the block of code will never be executed. Okay, so let's look at that. You also have to define an incrementer. Okay, so this for loop that we have here, right? Let's achieve the same thing with the while loop. Okay, so what I'm going to do here is I'm going to change this from for. Let's say while. Actually, no, let me do this. I'm going to copy this code. And I'm going to comment this out so we have it for reference, so you can see the similarity. All right. Now, what I'm doing here, we haven't done this yet, but this is called commenting out code. Any lines of code you comment out will not run. This is how you can add a comment to your code, and you can say, you know, I am doing this just for fun, right? This is an explanation to either yourself in the future, your future self, or to a developer as to why you wrote this particular block of code the way you wrote it. Okay? So this is called a comment. It doesn't execute, it does nothing. And you will see that as well as we go on. Now, this is what we had before. I want to convert this to a while loop. So I'm going to change the keyword here to while. And here, my condition, all I need in a while loop here is my condition, right? And I'll take out this increment. The difference is I need to initialize my I out here, and I need to do my increment in here. Okay, that's the difference. And so if I run this now, we get the exact same result. Let me move this here. The new, let's add new here so we can see. The new total is, if I run this, see that. So this is a while loop. You say while this condition is true, execute this code. It's straight English, like the link to English is direct in this particular keyword. While the condition is true, execute that code. Same thing, if I wanted to go backwards, right? If I started with I being 100, and I come here and we want to say while is greater than or equal to 1, and I change this to the decrement, right? And I run this, same thing. Okay, this time I'm just going backwards. So if we come to the top, this starting at 100, 100 plus 99 is 199, 297. So it's a different series, but it ends up at the same total. So this is the while loop. Any questions?
Okay. If the I dash dash that you added, that was something you just added now, right?
It was in the previous while loop, but this is, you have to change the value of I. If not, the loop is going to run forever.
I see.
So if I removed this here and I run it, it will never stop and it will just constantly add one. Or in this case, it will be 100. We can try it so you can see. It'll be interesting. But it will constantly add 100 until I probably get like a memory leak or something and it crashes. Anybody ready for this? See that? I use Control C to stop it, but you see it's adding 100.
I'm not.
Okay. All right. So we're going to move on to the last loop, which is going to be fun. And we're making good pace today. So this final loop here. Now this one is the African parent approach, right? If I mean, well, a lot of people here know what I mean. But with an African parent, you probably get a slap first and then they assess the situation, right? And so whether or not a crime was committed is sometimes determined after the action has been taken. So the condition comes after the block has executed at least once, you know. Also, well, there are many situations like that, but do something first and then decide whether or not you should have done it in the first place, you know. Some people know what I'm talking about here. So that is a do while loop. The difference between this and a while loop is that it will execute at least once. A while loop and a for loop may never execute, but a do while loop will always do something once and then subsequent times is conditional. And the syntax is similar, except that rather than while being here, it is do, and then you have the while condition here. So let's look at it. It's not very common either, but it's good to know that you can do that. So here we have a while, right? We're going to take this while here. We're going to cut that. I'm going to put it at the end here. And I'm going to say do, right? While this. Okay? And here, if we look at our condition, while I is greater than 1, let's make it while I is less than 100. Okay? And we'll have our I minus minus. Actually, let's make it while I is greater than 100. It's going to run once, then it's going to evaluate I. I is 100 here. This is false. It's not going to do it again. If we had this as a while loop, let's make this a while loop so you see. And we're going to take this while here. Let's just take this here, right? And I'm going to replace that do with that. Okay? And let's just initialize y again here. Or let's say, let y, or let x equals 100. And so while x is greater than 100, now if we run this, it only runs this. So the x, let's change the words here so it's clear. Let's make this the x total. Sorry, hold on. This is something here.
You got some WebKit cancel animation code wrongly in that line.
Sorry.
Your while
On which line?
your while statements.
Oh, right. Yeah. Sorry. I'm putting in Vim commands. Sorry. Yeah, whatever. And then I was trying to save. So this is it. Okay. So you see, it never runs this one, but it runs this. Just so that you know that this works. Let's make this 99 so that it happens once, right? Well, something's here. All right. So while x is, oh, sorry, my increment here is the problem. Let's run that, and there. It runs this once because it's greater than 99 only one time, and then after that it dies. So the difference between the do while loop and the while loop is that the do while loop, the do block is executed at least once, and then the for the while it's only executed if the condition passes. If the condition never passes, the code block never gets executed. Okay. So and that is it with our control flow or flow control. Okay. Any questions so far? Okay. I'm going to spend 5 minutes or so solving some common problems with what we've learned so far. Let's calculate. So we already did the sum of all the numbers from 1 to 100, right? How about we find the average of all the numbers from 1 to 100, right? So the average is the sum divided by how many numbers, correct? Is that correct? Anybody?
Yes.
Okay, so let's use the for loop. And I'm going to use the for loop more often because if you look at it, it's a little more compact than the others, right? All the setup is on one line, and then the block is followed. So it's cleaner to work with. So we use the for loop, and we're going to add all the numbers. So we'll find the average, which is the total divided by the count, right? That's also called the mean, right? So what we're going to do here is we're going to take this line out. And we're going to put that here, and we'll say the mean is, so we have the total, running total, we're going to say the mean is, that is our total divided by 100. If we run this now, this is the mean of the numbers from 1 to 100. That's the mean. Sadly, it's not 50 like we were hoping for. It's 50.5.
It's because you said 101.
Oh, I said 101.
Yeah, it was
All right.
100. It will be.
Well, so it is still less than and equal to, and let's look at that. I'll run that again. It is still 50.5. It's a weird mathematical situation, but that actually is the mean of the numbers from 1 to 100. Okay, because remember the total that we had was 50, 50. And if you divide that by 100, you get 50.5. All right. Okay, now, what if we wanted to output all the odd numbers between 100, 1 and 100?
But first of all, you know there are 101 numbers from 1 to 100.
Yes. Oh, there are 101 numbers.
No,
No.
actually,
Yes.
no, no, no.
No, there's
No,
hundreds.
there are
If you start
100
from
numbers.
if you start from 0, never mind.
Yeah, there are 100 numbers. Okay. Now, if we wanted to find all the odd numbers, right? Let's do this. I'm going to do this in one way, and then I'll do it with a ternary operator. So we'll say if, right, I, two numbers for this is one. So we're going to output all the odd numbers now. We say console.log I, no, sorry, I is odd. Okay. So we have that. And this here, I don't need this line. I can take that out. Okay. So if we run this, this should give us all the odd numbers. Between 1 and 100. Now, how do we get the even numbers?
The modulus is equivalent to 0.
Sweet. So let's go with that. So our modulus here has to be 0. I'll run that. Oh, we need to change this to even.
I can't keep up. Can you go slower?
No, but you can contact me after, okay?
Okay.
All right. So here, I is even. We want if. So this modulus operator, for those who don't remember, when you divide by a number, this is the remainder. If you divide I by 2, if the remainder is 0, which means it's an even number, we want it to log out, also log I is even. Okay? So that's, we're going to run that. And
Excuse me.
yes.
That's different from percentage. Trying to remember.
Yes, so in programming, this is not, percentage is a string.
Okay, got it.
But outside of quotes, it is not percentage, it is actually an operator. So it's the modulus operator. And it's the operator that gives you the remainder when you divide two numbers. Right? So 5 divided by 2 is 2, remainder 1. Right? So this operator is the remainder operator. So here we're checking to see if when divided by 2, there is, you know, there's a value. And so this gives us all the even numbers. You can see that. We can use this to see all the numbers between 1 and 100 that are divisible by 7. Right? And that tells us if the number is a multiple of 7. And if we run this, there, you only have the multiples of 7. Oh, I'm sorry, I went too far. All right, from here, you see that? 7, 14, and so on. Okay, and this is a simple loop. Now, if we wanted to find all the multiples of 7 between 1 and, okay, maybe 1,000, find all the multiples of 23. Just something weird like that. This simple program here will give us that. And this gives us all the multiples of 23.
Change the 7 to 23.
Yeah. Okay, these are all multiples of 23 from 1 to 1,000. 46, 69. There you go. Now, if you want to do something more complex, who knows what, or who remembers for the adults? I don't think the children will know this, but who remembers what factorial is?
Sounds like some.
Factorial is when you multiply something in
Decrementing.
Decremental, like 5 times 3 times 4. Sorry, 5 times 4 times 3 times 2 times 1.
Correct. All right, so let's say let factorial equals 1. We always have
back
to.
evil memories.
Yeah. So this is statistics. There's some people here who will remember this well, but like when you're doing permutation and combination, factorial is very heavily used there. And all kinds of weird stuff that some weird people like. So here we're going to decrement. So let's start with 1,000. No, let's just do 5 factorial. Right? And it always ends at 1, because if you multiply anything by 0, it becomes 0. So you don't go as far as 0. And we're going to go backwards. So we go with minus, minus. And call this minus rather than dash. So it's minus, minus. So your intention is clearer. All right. And so our factorial now is going to be factorial. And we're multiplying. So multiply assignment I. Right? We don't need these lines, so we can take out these lines. So 1, 2, 3. Right? And console.log the factorial is, and what's our factorial? Factorial. Okay. And if we do this, 5 times 4, 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So 5 factorial is 120. Now, what would 50 factorial be? Let's take this and let's change this to 50. And run this. And this is 50 factorial. It's a huge number. So this is a special notation, but this is times 10 raised to power 4. Right. So maybe we'll just do 10 factorial. Okay, that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is that. All right?
That don't make sense.
Okay. All right. let's move on to some more fun stuff. And we are spot on. We are right on schedule.
Unmute. Unmute.
Okay, let's talk about arrays. Now, remember we talked about different data types yesterday. We have strings, which are essentially letters, right? Or letters and numbers, but strings are defined in quotes. And then we have integers, which are whole numbers, right? And we have floating point numbers, which are decimals. And we have booleans, which are true or false. Now we have another data type called an array. It's not really a data type. An array is a collection, right? So if I wanted to say, okay, everyone in this class, I would put you in an array that would be the class, right? And that would be the collection of participants in this class. Then I can perform certain operations on each participant, or I can add participants to the class or to the meeting or to the Zoom meeting. The way Zoom works right now, it actually is operating off of an array. Each person that comes to join the room is added into an array of participants. Okay? So an array is an ordered, indexed collection of data. Okay? It sounds a lot more complex than it is, but arrays are very, very powerful and you will use them quite a bit. They're also very fun because it makes it easier to work with sets of data. Arrays, if you think in math, set theory, in programming, set theory and arrays are like that. You can find intersections between arrays. You can find the union of two arrays, right? There are many things you can do with arrays that literally map directly to sets in math. But we'll work with them here, and you're going to see it's going to be a lot more visual here than we did in math. So let's look at defining arrays. Arrays are defined using square brackets or square braces. That's what these are called. Okay. Now, remember, an array is an indexed collection, right? Which means each item has a spot. It's an ordered index collection. So if you have people stand in a line and you give them numbers, and you call number 1, the person that you gave number 1 will raise their hand up. If you call number 5, the person you gave number 5 will raise their hand up. Each person has a unique number. That's how arrays work. That number is called the index. Where is it in the array, right? What's the identifier within the array for that element, okay? So an array is an ordered, indexed collection of items. There's always a first and there's always a last. It's not random. If you call number 5, you will always get the element at number 5. You won't get any other, unless you remove that element and put something else as number 5. Okay, so let's play with this and let's create an array and let's see what we can do with an array. All right, so we're going to create an array of names. Okay, so we're going to say let names James, right? Sorry, let me put this as script. James, John, Jack, Anna, right? Here I have defined an array of names. My array has 4 items in it, right? So the length of my array is 4. But the trick with arrays is that arrays are what we call zero indexed, which means the first item is considered to be at position 0. It's very annoying, but once you get used to it, then it gets a little easier. But you always have to remember the first item in your array is not at position 1, it's at position 0. Because 0 is considered the first number. So when you're programming, a lot of time, your first number is actually 0 before 1. So you start counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you say the first 10 numbers, it will be 0 to 9, right? So the first item in an array is the item at point 0. And the way you access that is with, again, the square bracket notation and the index of the number you want to retrieve. Okay, so we're going to try to access the first name. So we'll say console.log, right? Names 0. And if we come here and we run this, sorry, I'm missing something here. Oh, yeah, undeclared. We say name is not defined, so I want this to be names. Save that. You can run this again. And the first item in there is James. Okay. Who can tell me how I would access this third item?
Where's the 0 to 2?
Okay, so let's change the 0 to 2. And that gives us Jack. And what would the last item be? That'll be 3. So if I change that, oh, sorry, to 3, this gives me the last item in my array. Okay. And there.
Is that a parenthesis or just normal comma?
Square brackets. Square brackets.
Okay.
So this is where you have the curly braces. It's the same button, but without shift. So square brackets for arrays. Okay. Now, remember what I said. An array is an ordered, indexed list of items, right? Which means that there are certain things you can do with arrays that make them really cool, right? Those actions you can perform on arrays are called methods. So there are different methods for arrays. There are methods for adding items to the array, for removing items from the array, for sorting the array, right? A very useful one is sorting the array. Okay, and then there are also properties. Now, just to understand what a method is an action that an object can perform. So let's say you have a car. A car is an object, right? What can a car do? A car can drive. A car can stop. A car can park, right? And then another aspect of objects is what we call properties. What are properties? A property is like an attribute of an object. A car can be blue, right? That's a property. A car can be big or it can be large. A car can be small. A car can have 5 seats, right? Those are properties of it. So the difference between a method and a method is an action that an object can perform. A property is an attribute of that object. We're going to deal with objects later, probably tomorrow. But for today, I'm just saying that because we're going to use some array methods and some array properties to play with our array. So how do you know if you wanted to console log the size of this array, right? Is size a method or a property?
Property.
Size is a property, right? Because the size of an array does not do anything. It tells me something about it. So let's look at the size of the main array. The property that holds that is the length property. So I'll say console log names dot length. Okay. And when I save that and I run that, gives me the size here, 4. I have 4 items in this array. Okay, that is the length. You can take this and you can save it to another variable. You can say let array size equals or be equal to names dot length. Right there. If I now come here and I say console.log array size, and I run this, see that? Okay. Now, how do I add an item to my array? Let's say I want to add another item, another name to my array, right? I'll say names dot push. That's the method for it. And I want to push that to my names array. And if I come here now and I copy this line here, and I paste it here, let's run this. So now I'm checking the length before, I'm checking the length after. See what I have? I had 4 items when I started. Now I have 5 items. And I can actually console.log to get the 5th item. And I run this, my 5th item is Barry. So that's how you add an item to an array. We're not going to go into all the array methods today. And at the end of this class, I'm going to show you how to find documentation that will help you, because there's a list of all the methods. You don't need to memorize them, but you can always look for them. And I'll show you how to do that. If I do that before this, before we close today. Okay, so now that we have this array, I'm going to show you one more method because it's a fun method. It's really cool. I have these names here. What if I wanted to sort them? Right? What if I wanted to sort them in ascending order? What would I do? I would say, let's do this way. Now, one of the good things about console log is that you can also log arrays out. So let's say console log names, right? If I come here and I run this, it gives me the array of names. Okay? Now I will say names dot sort. Sort is a method because I'm asking the array to sort itself. It will sort its contents. So if I now come here and I say console.log names, you will see a beautiful thing. My names are now sorted in alphabetical order.
I have a question.
Yes.
So if you now do, you know, array, let's say names dot 0, it will now be Anna.
Yes. So let's try that.
So this array is stored somewhere in memory.
Yes. So let's do that. Let's see. Names, 0, right? Let's see what we get. Anna. Because Anna, when you sort an array, then the indexes are reassigned. You get that?
Okay, fancy, yeah.
Yes, so the indexes are reassigned. So 0 is now this, 1 is now this, 2 is now this, 3 is now this, 4. When you sort. Now, so sort is a method. Can anyone guess how we can sort it in the opposite direction? Essentially, reverse, right? And the method is reverse. So if we want to flip the array around, we'll just say names that reverse. Let's try this. So if we do this, we have the array reversed. It's flipped now. It's now backwards. So it's now in descending order rather than in ascending order.
If you use that reverse before you do the sort, will it just reverse whatever, however you arranged it originally, or will it always be a sort reverse?
No, it will just reverse whichever way it was. So if we reverse this, James will go to the end, like it would literally flip around. And we can try that. So what I'm going to do is I'm going to remove this sort, right? I'll remove the sort here. I'll comment it out so it doesn't do the sort. And then we'll just do a reverse. If we run this, you see that? It's still mixed. But here, James is first. James is now last.
Okay, cool.
Barbie was last. Barbie is now first. So a reverse will just reverse it. So if you want to, if you have a list and you're like, hey, I want this in, ascending order, you just do a sort. If you say you want it in descending order, you do a sort and then you reverse. And that's how you get descending order. Okay. There are more complex sorts that you can do, like you can do a custom sort. But that's outside the scope of right now. But you can do a custom sort, and that allows you to write your own sort function. So we won't do that right now, but as we go along, we may come across a place where we need to do that. Because some things are not easily sortable, right? Like if you have an array of objects, you want to sort. You can't sort by objects because they're not comparable, but you can sort by maybe a property of an object, right? So that's fun with arrays. Now let's see if we can bring in what we've learned before. What if I wanted to loop through this array and output all the names in the array one after the other? Anyone?
You could do one of your loop ones.
Okay, so let's use our loops. So keyword.
Yeah. Oops.
For. Yes.
Loop.
So for let I equals 0, because we want to go, the array starting at 0, right? Okay. While I is less than
4.
Well,
no, 4.
We can just do the length of the array, so we can do names.length.
Oh, yeah, okay, good.
Right? We can do I plus, right? And then we can say console.log names. Does this make sense? So we're starting from 0, and we will go until we get to the last item. But remember, we're using less than because we don't want to, this array has 4 items. We don't want to get to index 4 because index 4 of an array is actually the 5th item. One stop at index 3. So if we go to less than the length, it will be 1, 2, 0, 1, 2, 3. It will stop before 4. And then we increment here. And we can use a variable because this I is a variable. So it's going to be at index 0, at index 1, at index 2, at index 3. So if we run this, so I've saved that. If I run this, there. It's outputting each item in the array. So arrays are great. They're collections, and you can look through them. You can look through them like this. I will show you a better way of looking through them, but not today. I was gonna show that, but it's a little bit of a complex concept. So there's a method on an array for actually looping through it, and it's called for each. But I won't show them right now because there's a concept I haven't taught yet that'll make that easier to understand. But this is arrays. Okay, this is looking through the array. One last thing I would show you. What if I wanted to join all of these together and turn it into a string? Anybody? Can anyone guess? I used the word there that sounds like the name of the method, right? I want to join all the elements together.
Well, I'll use the lazy method of doing like a concatenation.
So you can do the concatenation in the loop, right? Like we could say, let all be the string, right? Let all be an empty string. And then here we can then do, this is not him. So here we can say all, right, plus equals names I, right? That's what you're saying, right? That's the concatenation.
So yes.
And then here at the end, I can say console.log all. And that gives us all the names joined together. You can do that. But there's an even easier way because arrays have a capability of doing that by themselves. What you can do is, you see, rather than all these lines of code, I can just say console.log names.join. So the names array has a join method on it that will essentially join all the elements together. And if I run this, we get the same result, except that we have a comma there, right? So you see that it's joined it, James, John. Now, if I wanted to join it without that comma, I would put an empty string there and say, hey, join it together without the comma, and we get the same result as before, right? But let's imagine I wanted to join it with something fancy, like XX, pound, pound, XX, right? If I do that here, see that? It's separating each one with that. And maybe I wanted to put a comma and a space. You can do that. You can say comma, space. And this method here, this particular one here is something you will do often where you have a list of an array of things and you want to create like a comma separated list with a space so it makes sense. This here will do that and it will give me a list of names. John, comma, space. Okay. So there are many more things you can do with arrays, but I wanted you to get the concept of dealing with a collection. That's what an array is. It's a lovely thing. It makes, you can relate it to real life. If someone has 5 cars, you create an array of their cars. Honda Accord, Honda Civic, Toyota Corolla, whatever. That's an array of their cars. If you have 5 fruits, you create an array of fruits: banana, orange, apple. If you have 5 dogs, you create an array of your dog names. So wherever you have a collection that you want to work with, you create an array. The items in the collection don't have to be similar, they don't have to be related, right? But more often than not, you work with an array of similar elements. Okay? Okay. One last topic.
Can you quickly explain after join what you had in the bracket?
Okay. So the string here is called the glue, right? Like literally the technical term for what is in join, what you provide, is the glue. And that is what will be stuck, will be put in between the elements of the array when they're converted to a string. So the join always gives you back a string, right? And then the glue is what is used to join them together into a string. It sounds like real life, but it kind of is a technical, parallel to what happens in real life. You have elements, you join them together into a string with some glue. That's it. Okay? All right. Let's look at one more concept, and we're going to look at the most simple version of it. So we've kind of looked at looping, but we'll come back to it. We're going to look at functions. And we're going to look at functions very quickly. Okay? Functions allow you to reuse a block of code. Okay? If you have, there is what is called being dry. As a good developer, you need to be dry. Do not repeat yourself. There's someone I worked with many years ago that said a good developer is a lazy developer, right? If you solve the problem once, if you've written a line of code, you don't want to solve that problem 5 times if you need it solved 5 times. You solve it once in a way where you can reuse that solution. And the way to write code that is reusable is using functions. Methods are functions and objects because they do something. You get what I mean? So we're going to very quickly just write a loop that squares numbers, and you will see how you can make a function to do the squaring and output it to the screen. Okay? So declaring a function is simple. Use the function keyword. And then you specify an identifier for the function. So we'll call this square, right? And this right here is a function. We now have a block of code that this function can execute. So you say console.log I have been squared. Right? If we needed to in many different places. When we're writing some of the code earlier on, I was copying and pasting and copying and pasting and copying and pasting. We call it copy pasta. That's a bad thing. Whenever you need to copy and paste, you need a function. Most times when you need to copy and paste, you should consider writing a function, because that means you're repeating exactly the same thing, right? And maybe changing a value. So we copy and paste and then I adjust the value, copy and paste and then I tweak a value, copy and paste and tweak a value. That's not great. So a function helps us avoid that. So here, if I want to do this and I say square, this is how you call a function. Just type the identifier. Let's name it square me. Okay. Yeah, okay, fine. Let's go with square. Right? If I say square like that, and I run this, right? You see that? It calls this function and executes the code inside it. If I come down here and I call square again, I'll just call it again. Now, you see, it calls that same function. The benefit of this is if I decide I want to change the text in here to I was being squared, I only have to change it in one place, and everywhere that function is used, it's changed. So our functions are very important. They help you organize your code into reusable pieces.
Sorry, is it correct to assume these your functions, they are like formulas that you can carry from job to job, and you can continue using it wherever you have a similar situation?
Yes. Yes. So, and that is a really good, that's a really good analogy. It's a formula. Now you may change the parameters, the values that you use in that function, right? But it will do the same math. Let's say and this brings me to the very next thing I want to talk about, which is parameters. If I wanted this function to perform an operation on specific values, right? How would I do that? I would need to be able to pass values to the function, right? So let's say I want a function to calculate the area, right, of a circle. So let's say circle area, right? And I want to pass a radius to it. I would define a parameter called radius. This essentially defines a variable that's available within the function, right? Now within my function here, let's calculate the area of a circle. We need pi, right? So const pi equals 3.14, right? Is that right? And then const area, const area. What's the formula for the area of a circle? It will be
r squared
pi, right? Times radius. Remember the exponent operator? 2. And we want to make sure that we do the exponent, right? So it's the radius that we're squaring, not pi times radius all squared, right? And so here we can now say console.log the area of circle with radius, right? Radius is area. And now I can call this method, I can call this function to calculate. So circle area, and some kids are going to be using this for their math homework now. The circle area 10. And so if I run this here, circle area 10 is 314. Oh, sorry. I did something here. So the area of a circle with radius 10 is 314. Now let's do one last thing and we'll end the class. Let's do a loop and find the area of circles between 10 and 1000 in increments of 10. So for let I equals 10, right? I less than or equal to 1000 or 100. I plus plus. Let's see. Well, okay, yeah. Let's just do plus plus. It's easy, right? And then we're gonna say circle it. Come on. Circle area I. And if we run this, there. That's the area of the numbers from. So that's the beauty of a function. If I want to tweak this, so I can call it from within a function, I can call it from outside. I mean, I can call it from within a loop, I can call it from outside a loop. There are many different ways, but that is what a function does in its most basic form. It gives you reusable code. Okay, tomorrow we're going to use functions more. A lot more of what we're going to do tomorrow will be function. We'll have more functions, but it's all the same concepts that we've been using. They'll come together.
Excuse me, I have a question.
Yes.
I noticed the radius wasn't defined. Is that why it was undefined at first?
Yes, so here, and that you mean here, right?
Yes.
Yes, so when you do it like this, you are making it a parameter, right?
Okay.
So it is not initialized. And we'll talk about it more tomorrow when you can initialize it to make it optional, right?
Okay.
But right now, it's not initialized, which means the value that you put in here is passed, is set. So that is where it is initialized. Is whenever it is called, you provide the value for it. And that's the power of functions. You can do the same thing on many different values. What you do is when you call it, you pass the value you wanted to operate on or you wanted to use. Okay? Tomorrow we're going to do a lot more with functions. So functions will become second nature because it is a basis, but we're going to constantly build on the things that we've been learning. Okay? So like you can see, everything we've learned before, we're constantly using. We're going to constantly be using them and we will remember them. Okay? Any questions? Any other questions? And this brings us to the close of the class. So we'll take a couple of questions, and if not, then let's check temperatures again. Any questions? Okay, so we'll end the class here. I'm going to stop recording.